Okay, going back, we have 4 buses, 5 lines. Okay? So, dun sa pag-create natin ng Y bus, dun sa off-diagonal element, kung ano yung admittance between row 1, column 2. Sabihin yun, bus 1 and bus 2. Actually, ito, yung admittance dito will be the same as the admittance dito kasi between ano naman, bus 2 and bus 1. So, ganun ang ano ha. Kunin yung admittance times -1 and eventually get kung meron man siya. So, these are the steps for the Y bus. Itong slide na to. So, if you get this one, okay, di ba? Sasum lang yung off diagonal. Tapos yung diagonal, sasum lang yung connected sa kanya. Whereas dun sa off diagonal, kukunin mo yung admittance kung meron. Like for example, may nakita kayo ditong 0 kasi between bus 4 and bus 2, so row 4, column 2, wala kang makikitang linya between bus 4 and bus 2. So walang linya diretso. So that's 0. Kaya 0 dito. So this is your Y bus. Pero dito class, dito sa notes na nandito, ang ginawa lang, yung B prime, okay, is actually tinanggal lang niya yung first row and first column. Yun kasi yung ginamit niyang pivot. Kaya nakikita nyo, nag-start na sa -20, 10, 0. But eventually, at the later part, excuse me. Eventually, at the latter part, hindi naman natin gagamitin yung B prime. B ang gagamitin natin, where yung B is just equivalent to your Y bus. Okay? Mamaya. Now, we get the Y bus. After naman yan, if you remember this equation kanina nung nagde-derive tayo, the power flow along the branches is equal to the D matrix times the node arc incident matrix A times yung angle na theta. Okay. How do we determine the node arc incident matrix A? We determine that by just getting sige, Jay, ano yung tanong? Jay, may tanong ka ba? Nag-raise ka ng hand eh. Hello? Jay, may tanong ka ba? Ba't ka nagtaas ng kamay sa Zoom?
Wala daw sir marinig.
Walang marinig. Ganun ba? Try mo uling log out, Jay. Baka kasi ang may problema yung mismong laptop or desktop mo or kung saan ka nakakonect. Wala ka bang cellphone that you can use? Paano ba nakakausap si Tristan? Nakakausap mo ba siya sa phone?
Nakita ko lang sir sa chat. Sa chat box.
Oo, kasi wala daw siya marinig pero siya lang yata hindi nakakarinig. Ayun pa lang, connecting to audio pa lang siya. Ito, naririnig mo na, Jay. Mukhang connected ka na. Mukhang may problema yung laptop or desktop mo, Jay. Okay na? Naririnig mo na? Mukhang may audio ka na eh. Sige. Hindi ka nagsasalita. Yan. Okay na. 10 minutes bago ka mag-reply ah. Okay. Continuing on. Paano ba natin ma-determine yung node arc incident matrix A? Doon sa node arc incident matrix, kung ilan yung number of branches mo, yun yung number of rows mo. Kung ilan yung number of buses mo, yun naman yung columns mo. So ang ating number of branches 5, whereas yung number of buses natin 4. So we will form a 5x4 matrix. Now in your transmission line, you will assume, parang if you remember your Kirchhoff's current law, no? Gagawin natin dito, we will assume a flow, a power flow. Like for example, you see these arrows dito sa shared na PDF. Ito yung i-assume na flow natin for this problem. Like for example, for line 1, ito, line 1 is between bus 1 and bus 4. Ang in-assume niya, ang flow is from bus 1 to bus 4. Whereas for bus 5, ang flow is from bus 1 to bus 3. So yun yung in-assume. Now, how do we get the node arc incident matrix? Okay? Ito medyo putol to, no? Kasi ang ginawa na naman itong problem na to, tinapyas niya yung column 1. No? Pero I'll show you yung dapat na incident matrix, ha? I'll share my other file. Okay? So we have nakikita yung Excel file ba? Ria, ikaw ang mag-confirm. So, nakikita mo yung Excel file. Okay. Now, sabi ko kanina, ilan yung buses? 1, 2, 3, 4. And then ilan yung branches? 1, 2, 3, 4, and 5. Ang sabi sa node arc incident matrix, pag the branch is away from a certain node or bus, use +1. Pero pag going towards a certain bus or node, use -1. Okay? So balikan natin to. So for line 1, ito yung magiging row number 1 natin, yung line 1. It is between bus 1 and bus 4. So sabi, pag from 1, pag towards, -1. So galing bus 1 towards bus 4. So gagawin natin sa Excel. From bus 1 towards bus 4. So -1. Then yung wala, just put 0. Line 2 is from bus 1, ito yung arrow eh. From bus 1 to bus 2. So 1, -1, 0, and 0. Okay? Next. Line 3 is from bus 2 to 3. From bus 2 to 3. Line 4 naman, ito is from bus 4 to bus 3. From bus 4 to bus 3. And finally, line 5 is bus 1 to bus 3. Bus 1. Ito na yung, tanggalin ko na yung, yung columns na yan. Yung parang marker natin for, Ito na guys, yung node arc incidence matrix A. Okay? So, balikan natin yung kanina, B matrix. Kopyahin ko to para lalabas natin lahat. Gagamitin natin. Yung B matrix is just the Y bus. -30, 10, 10, 10, 10, 20, -20, 0, 10, 10. Okay, so we have the B matrix. Okay? So meron tayong node arc incident matrix tsaka B matrix. Next. So ayan, nakita nyo. Tinanggal lang yung column 1. Yung pinakita, ito na lang. Itong part na to. Ito yun. 0, 0, negative 1, negative 1, 0, 0. Diba ito yun? Okay? Next. Now, let us get the D matrix. Very simple lang D matrix. Kunin lang yung value ng admittance. That's it. Okay? Pag row, kung ilan yung branches mo, that's your number of, ito, nakalagay nga, the D matrix is formed by placing the admittances of each branch along the diagonal. So, branch 1, branch 2, branch 3, branch 4, and branch 5. Nagkataon lang puro 10. And then the off diagonals, all the rest will be 0. So, magiging 10. So, 5 by 5 matrix kasi because we have, tayo dito, 5 branches. Okay. Okay, so this is your D matrix. Okay. Now, you have to get the kunin natin yung product ng D times A. Pero guys, balikan natin wag nating tatanggalin yung first column sa A matrix na wala tuloy yung theta 1 dito kasi ginawang reference bus siya. So for the problem, wag nating gawin yung ginawa nung nasa notes, but instead, let's just get D times A. Huwag natin tanggalin yung first column. Naalala naman yung pag multiply. So 5 by i-multiply mo yung D na 5 by 5 sa 5 by 4. So ang lalabas 5 by 4. So i-highlight natin itong 5 by 4. Then mult 5 by 5 times 5 by 4. Oh, sumobra pala. Yan. Ito na yung D times A natin. Dito sa power flow equation for the branches. Okay. Now, linear programming with DC power flow. So this is the standard form or format of our objective function. You have to minimize the cost function Z that is equivalent to, kasi nga linearized na siya, no? Dati guys, quadratic equation siya, no? Ginagawa pa natin yung Lagrange, then partial derivative. Pero dahil ni-linearize na yung problem, sabihin nun, first order na yung equation, makikita nyo, meron lang constant, ang generator na lang ngayon is represented as yung x1 would be yung variable mo na x, yung generation, whereas yung c, yan yung magre-represent na price. So C1, X1 plus C2, X2 plus so on and so forth. Okay? Subject to a set of constraints. No? Ito na naman yan. Using the same example, derive the LP format of the DC power flow, whereas yung cost function mo ay ito. Okay? So, yung generator natin, i-represent natin ng 13.07 times P1. Yung presyo niya, 13.07. P1 is the unknown pa na generation. 12.11 times P2 plus 12.54 times P4. Okay? So, whereas yung z of x na objective function natin, pagka nalala, no? Pagka matrix form yan, actually, yung naka-pivot yan na ganyan. So technically, ang equation mo talaga is 13.07 times P1 plus 12.11 times P2. So magkakatapat na ganun. Then the rest is just branches, pero technically, wala namang cost yung branch flow and yung angle sa buses. So ibig sabihin yan, puro zero lang ang ilalagay. Okay, this is our subject to the power flow equations. So let us try to build yung tinatawag nating equality constraints into a matrix that is equivalent to A equivalent times X is equal to B equivalent. Now we have to note the dimensions are, para makuha natin yung A equivalent, okay? No? We have a solution vector X na 12 by 1. Ito yun. You count this, 1, kasi yung unknown mo to eh, P1, 2, 4. So unknown yung P1, P2, and P4, yung generator na tatlo. Then you have branches na 5. That's a total of 3 plus 5, 8 na, plus angles na 4. So you have 12 unknowns. Wala natin ma-figure out 12 unknowns. Pero yung number of rows mo naman, okay, is based on kung ilan yung how those equations will be constrained through the number of branches and buses. So ilan ba yung branch and bus natin? We have 5 branches again and 4 buses. So now we have a total of 9 rows. So now our A equivalent will be 9 by 12. Remember the D times A matrix, nakuha na natin yan. Okay? So pag form down ng D times A, yung A equivalent, dito ako sa baba, you have to have 12 columns. Yan. And then we need 9 rows. Okay. Dito natin ilagay yung A equivalent. Okay. Ito pa naman. So sabi, yung sa rightmost side, yung sa rightmost na 5 rows and 4 columns, doon natin ilagay yung D times A. So ito. Yung D times A, ilagay natin sa rightmost 4 columns at 5 rows. Ayan, dito. Okay? Kuha. Next. You get the diagonals to be -1 lang kasi pag pinivot yan, represents the unknowns for, pag pinivot itong ano na to, itong unknown na to, at pinivot mo yan, yan yung nagre-represent sa magiging unknown na branch 1 to 5. Okay? So get the diagonals lang. Kasi parang ito yung branch 1 would be equal to this. And then all the rest, put 0. So sa part na to, sa leftmost na 3 columns, since ang unknown natin na i-reserve dito is gen, we just have to put zeros in this column para hindi mag-conflict. Puro 0. Next, paano naman yung sa baba? Okay, paano yung sa baba? You get the B prime, which is, if you remember, wala na yung tinanggal yung first row and first column, no? Gagamitin din pala. B prime. Get it and put it at the rightmost, at the lower right. Ito na yan. Since nakuha na natin yung equations for branches sa side na to, sa side naman na to, hindi na natin kailangan. Kasi ito yung magre-represent naman. Yung lower 4 is for the buses and the generators. You remember, this one, this 12, actually represents, yung kanina nga pinivot natin, di ba? This represents P1, P2, P3, branch 1, B1, B2, 4, B5, and then bus 1, bus 2, 3, and bus 4. Yan yun, di ba? Ito yung naka-pivot mong ganito. No? Yun yung may angle na theta. Natin. Okay, ano lang. So, ito yung angle theta, no? Represent lang natin. Okay. Diba? Yan yun. Okay. Now, once we got this, yung generator 1 kasi, located, actually P1, P2, and P4 yun eh. Tatlong generator. Pero yung third generator is located on bus 4. So, like for example, kung dito yung, this sixth row represents bus 1, 2, 3, and 4. Ito yun, di ba? Same lang yan. So P1 will just be here, placed here kasi nasa bus 1 siya. P2, syempre nasa bus 2. But yung P4 is not at bus 3. It is actually at bus 4. So nandito siya. So then we'll have to put the others at 0. Kasi wala tayong generation sa bus 3. Okay, yan. Yan yun. Okay, ito na yung A equivalent. Okay. This is your unknown. Di ba meron niyang equal to B equivalent. Yung B equivalent, ito na yung X, unknown. Whereas your B equivalent is equal to your requirement, yung mga consumption or loads. So yung first rows are 5 branches and then the last 4 are your buses. Sa first 4, 5, ang branches naman, walang requirement, di ba? So ano yan? Gawin natin ulit ito. Wala naman requirement ang branch eh. So 0. Sa bus 1, if you remember our drawing, balik tayo sa drawing natin. Yung original, ito. Sa bus 2, merong load na 1. But you represent that sa consumption as negative 1. Sorry. 0 pala sa bus 1, negative 1 per unit. And then yung bus 3, negative 1.1787. Then 0. Yan. Now we have this A equivalent. So kung titingnan mo, this is 9 by 12. Di ba? Product yan times, ilan to? 12 by 1. Magiging resulta mo, 9 by 12 times 12 by 1, di 9 by 1. Which is yung unknown natin na mga bus and branches. Okay. You now have your A equivalent. Let us now form the inequality matrix. Kung ano yung mga limits ng generator 1, 2, and 4. Ano ba yung limit ng branch 1 to 5? And ano yung limit ng angles ng theta 1 to 4? Sabi doon sa problem, per unit dapat ang representation. Okay, so may 10 minutes na lang ulit tayo. Kung kaya nang matapos. 0.5. It's been ng 0.5, di ba naalala niyo naman yung conversion ng per unit. So in actual, ang actual nito 50. So 0.5 times 100 MVA base, di ba? So lagi naman yun yung base MVA unless sinabi na otherwise ang reference MVA or base MVA natin 100 MVA. So pero again, that's the same as for megawatt and megabar. Ayoko nang magbalik kung ano yung ginagamit sa sa per unit, but how per unit is used. But essentially, P1 has a capacity of Pmin of 50 megawatts and has a Pmax of 200 megawatts. So in per unit, divide mo na ng 100, that will be 0.5 and 2. Meron din sa P2, sa P4. Now may clerical error lang dito yung branch dito hindi na per unit. Dapat ito 500 megawatts eh. Pero dapat divide mo ng 100 for it to be per unit. dapat ito 5 per unit, hindi 500. So, kung 500 kasi ito, 500, maging 50,000 yung linya and there's no such thing. So, bakit negative? Kasi if you have an AC line, bidirectional siya. So, your power flow, kasi kanina inassume natin doon sa power flow, di ba, from sa node arc incidence matrix, yung A, di ba, inassume natin na from bus 1 to bus 4. Pag ginawa natin yung branch na limit 0 sa leftmost dito, tapos 5 dito, mako-constrain natin yung problem na ang flow lagi is from bus 1 to bus 4. Pero AC ang line eh. So it can also be from bus 4 to bus 1. Inassume mo lang yung node arc yun, inassume mo lang. Pero pag ang lumabas, iba, kunwari, ang lumabas sa branch mo is -10, ibig sabihin nun pala, ang flow, hindi bus 1 to bus 4, but rather bus 4 to bus 1. Okay? So kaya negative yan para dahil bidirectional. Okay? Same with your angles, bidirectional siya, 180 degrees. So from -pi to pi. Now this is your standard form. Guys. Ito yung A equivalent X. Ito, minimize the cost function Z of X. Ito yon, yung kanina. Subject to the A equivalent times X equals B equivalent. And your inequality constraint. Tandaan na, meron dyang, your branch, for example, P1 should be greater than or equal to 0.5, but less than or equal to 2. So may less than equal na notation yun, ha? Okay. So this is your equation. If we use linear programming in MATLAB, we will solve this value. Ito yung magiging ano. Tingnan nyo yung nakita nyo sa branch 1. -0.0152 per unit. Pagka tinanong, in megawatts, ilan yan? Times mo lang ng 100, that's 1.5 megawatts. Pero dahil negative, di ba, inassume natin sa branch 1 ay bus 1 to bus 4 sa node arc incidence matrix. Ibig sabihin pala, hindi bus 1 to bus 4 ang naging resulta. Bus 4 to bus 1. Okay? Ito yung magiging final solution. Ayan, di ba? From bus 1 to bus 4, dahil negative, pabaliktad pala yun. This is the MATLAB code. If you want to solve it, and you will get that solution. Okay? Now, that ends yung lecture natin for linear programming. Okay? What I will do is I will send you this. Meron na ba kayong copy nito, guys? Vanessa, meron ka namang copy nitong lecture na ito? Nabigay na ba lahat ng lectures nyo?
Wala pa, sir.
Wala pa. I'll send this through Viber. Maliit lang naman to. Once I send this, I will also send yung second exam nyo because I will ask you to solve a linear programming problem. Okay? Itong gantong format lang. Ang kailangan ko lang up to the level ng kung anong format. Kailangan mapakita nyo kung paano nyo siya na-form tulad ng ginawa natin kanina. And eventually, gusto ko makita yung standard format. Ito, LP, OPF in standard form. So you will have 3 problems doon. Okay? I will send it to you today. And Junia is on Monday. Sabihin ko rin instructions. Then on Tuesday, we will have another class sa gabi. Lahat ba kayo nagwo-work from home? Pwede nyo i-off na yung ano nyo, yung para marinig ko kayo. Stop ko muna tong video.